All right, problem one of factoring out. If we break it down, we don't have to. We could look at 6n, 8y and say, hey, what's a number that can factor out? What's the greatest common factor they both share, which is going to be a 2. You can see they're both even. 2 is the biggest thing that can be factored out. But if we broke it down and we broke the 6 down to its prime factorization of 2 times 3n plus 8 breaks down to a 2 times 2 times 2 times y, we then would see, hey, he has a 2, he has a 2, and that's only thing they share. So a 2 factors out, and you're left behind with a 3n plus 2 times 2 is 4y. Okay? That's how, if you wanted to break it down, you could do it. But let's say that you just sort of want to look at it and say, hey, 6n plus 8y, I can see a 2 is the only thing that factors out. So 2 times what gives me back my 6n? Well, that's 3n. And now 2 times what gives me back my 8y? Well, that's going to be 4y. Either method is fine. Personally, this is the method most of us would go with. But since we're starting this out, we might need to see exactly what's occurring, which is that. Problem number 2. Again, 5, 15, we can see, hey, a 5 is what both of them share that can be factored out. But again, if we write it, 5, n, 15 is a 3 times 5 times n times n. And now we factor out a 5. That leaves us also an n and an n here, and an n and an n here. That's going to be n squared. And so we factored the 5 out and the 5 out. What was left behind? An n plus 3. And that's what we would get.